Hello, everyone, and welcome to today's Ask Tom live session. I'm really excited for today's session. What we're looking at is something that represents many years of work by Tone and other people within Oracle here. We're looking at one of the key features in the upcoming RU for Oracle AI database. That's SQL assertions. This is something that finally kind of closes the gap in terms of database integrity and constraints, being able to kind of enforce some really complex rules. So today is kind of patching day. The RU is due. I mean, it'll be Pacific time before things actually come out properly. So sometime later today, things should start kicking in, and we'll see the next release of Oracle AI Database 26 AI coming out and being available for you to actually play with this feature, which is coming in this release. So with that, I just want to say, pass it over to Tone Coplars, the software architect and brains behind this feature. So over to you, Tone, and take it from here.
Hey, Chris, thanks. Hello, everybody. Really excited to talk about this feature. I've been working on this intensely the last 5 years mainly. So what we're going to talk about today is SQL assertions, which are generic multi-row constraints. I'm going to give you an introduction into the feature, but I also would like to share some of the internals, how we do stuff under the hood, which will probably answer a bunch of questions that some of you may have while I start talking about this feature. So let's start straight away with a simple example database design and a few example assertions. I'm going to create a table dept and emp. So I have my dept table here, and you're probably in this session because you currently use constraints already. So what I have here is my dept table decorated with a bunch of constraints. I have two check constraints, forcing that dname must be uppercase and just three allowed values for the type column. And I would like to refer to check constraints as single row constraints. They must be true inside each row. They span the context of a single row. In contrast, these other constraints that we already have, the primary key, the unique key, for instance, I refer to those as multi-row constraints because they must be true for the full set of rows in the table. And SQL assertions are basically going to give you a generic way to specify even more multi-row constraints. So here's my emp table. Again, I have a bunch of check constraints in it. Job must be uppercase, salary must be greater than 10. If you're the president, then you don't have a manager. And if you're not the president, then you must have a manager. And then again, I have a primary key and two foreign keys, one going up to the parent table, department number, and one self-referencing foreign key from emp node to manager number. And again, the foreign key also is a multi-row constraint. It's even sometimes a multi-table constraint, for enforcing some condition on the contents of two tables instead of just a single table, but still multi-row constraints. Now, very often your database designs they have more multi-row, multi-table constraints. And with SQL assertions, we're going to give you a way to specify those and to declare them inside the database so that the database can take care of them. Now, I have a simple example here. Let's assume I want that all the employees who are of job controller, that they must work in a finance department, right? So if I go back to my previous slides, so if your job is controller, then you must work in the finance department. Let's assume that's a constraint that I want to specify. Now, how do we specify these types of constraints in a generic way? Now, the way to do that is to write a query that searches for a violation. So let's try and find a controller that does not work in a finance department. Yeah, it's a very simple query. You join emp and dept, and you look for a controller whose department is not of type finance. And the way to specify this constraint now is then you stick a not exists on top of it. So you basically tell the database this query may never return a row. So not exists a controller outside finance. By sticking the not exists on top of it, this is now a Boolean expression, and the database will be tasked to keep this expression true at all times. Let's look at another example. You cannot earn more salary than your manager. A classic example, I had the self-referencing foreign key from employee number to manager number. Again, I'm going to look for an employee who earns more than his or her salary. So I'm doing a self-join of emp via the employee number foreign key up to the manager. And I'm looking for an employee E whose salary is greater than the manager's salary. Yeah. So E is the employee because I'm using that foreign key to join to the manager, to the primary key of the manager. And then again, a stick not exists on top of it, and I have specified in a generic way this business rule, this multi-row constraint. Here's another example. Let's assume that we do not allow more than one employee whose job is president inside the employee table. How do we specify those types of constraints? Well, I'm going to look for two presidents. I'm going to say that that's not allowed to exist. So I'm basically, well, not joining employee with itself, but I'm looking for two employees, E1 and E2, whose job both is president, but they are different rows. Yeah, E row ID unequal E2 row ID. I could have used employee number here as well, given the fact that employee number is a primary key. I personally prefer to just use row ID. So now I've specified that there cannot be two presidents, and that also means that there cannot be three or four or more presidents, because if there are three, then this query would already return a row. The last one, let's say I also want to mandate that in the employee table, there must at least be a row whose job is president. So this one's slightly different. Now I have to basically search for this president. And instead of sticking a not exists, I'm going to stick an exists on top of it. Yeah, so a very simple query. I'm looking for a president, and I'm going to mandate that this should return a row. Exist, select the president from emp where e.job equals president. Last one. Now I'm going to introduce a slightly more complexity into this. Let's say I want to have the following business rule. Every manager must have a clerk in the same department. So I cannot have a manager in a department when there's not a clerk also in the department. Yeah, so I'm going to search for a manager without the clerk, and again put not exists on top of it. But what we're going to get now is we're going to get a nested subquery. So I'm looking for a manager, select from emp where job equals manager, and not exists in the same department a clerk. Yeah, and managers without clerks are not allowed to exist because there must always be a clerk, so I'm sticking the top level not exists on top of it. Now this is slightly more complex because of two things. Obviously there's a nested subquery going on, but also you see two negations here, right? I have not exists here and not exists here. And negations are typically more difficult for us to immediately understand. So I'm going to come back to this phenomenon because we will have a solution for this to make it more easier as well. So, but wouldn't it be great? I've given you now 4 examples. If we could declare all these Boolean expressions inside the database. And that's what SQL assertions is all about. SQL assertions is going to allow you to declare all these 5 constraints, multi-row constraints in the database. Yeah, so what we're going to give you with this RU is a new create assertion command. So I'm going to talk about the syntax of creating an assertion. I'm going to give you 3 demos as well. But I want to also give you a little bit of insight on the internals. So some of you may already be asking, well, is this going to perform at all? So I want to explain a little bit on how we how we do the revalidation, and hopefully give you a reassurance that this will perform as good as it would had you built your own triggers to do this. I also need to explain to you that there's concurrency implications involved. For those of you who've dealt with foreign keys, for instance, in foreign keys, there's also concurrency implications involved. So I'm going to explain to you that. Then we have this new all satisfy syntax, which is going to make the nested negations go away. I'll talk about that, and I'll have some wrap up where I discuss the full scope of the supported syntax that we're going to provide you this month, this week, today. So SQL assertions is not something that I or we at Oracle invented. It's been in the SQL standard since 1992. I found actually a 1992 SQL standard here. I have the URL here. And if you look at section 4.10.4, there's assertions. And in the standard, it says an assertion is a named constraint that may relate to the content of a row, which is a single row. It may relate to the content of rows of a table, the entire contents of a table, or a state required to exist between a number of tables, so multiple tables involved. An assertion is described by an assertion descriptor. I'll come to that on the next slide. And in addition, you have this search condition. And the search condition, that's the Boolean expression, where you can now have queries and nested subqueries. An assertion is satisfied if and only if that search condition is not false. Yeah? So again, it's been in the standard for what, over 3 decades now. I think we are going to be the first database vendor who's going to give you this feature that's been in the SQL standard forever. So what's the syntax? You have create assertion, you give it a name, check, and then the search condition. And then you have the same descriptors or properties that you are familiar already with the constraints that we currently provide. Yeah? Some of them do not apply for assertions, but assertions, they can be deferrable or not deferrable, initially immediate or initially deferred. By default, they will be enabled and validated, but you can create them disabled and not validated as well. And that search condition, that's the Boolean expression. Yeah? So there you're just going to plug in the not exists or the exists, and then the subquery that specifies the generic multi-row constraint that you want to declare to the database. And again, they're just like constraints. So the default would be that assertions are enabled and validated, which means that the current data will be checked and must be okay for create assertion to succeed. And once it's created, because it's enabled, all transactions will from then on be enforced to comply with the SQL assertion. You can also create them in enable no validate state, which would typically be a lot quicker if your tables already have a lot of data, because the current data is not checked, but new transactions will be enforced. And you can have disable no validate, which is basically just dropping the assertion in the data dictionary and otherwise nothing happens. Just like constraints. Now, unlike constraints, assertions are a new schema level object type. Yeah, so currently constraints, they are attached to a table. You don't have a create constraint command, but with assertions, we will have a create assertion command, as well as create auto drop any assertion command. Sorry, system privileges. And we're tracking them in user all DBA assertions. Now, note that DBA assertions also has an object ID here. So we're also tracking them in DBA objects, where object type equals assertion. And in the definition SQL, that will hold the Boolean expression that you provided while you did the create assertion. There's also, next to the system privileges that I had on my prior slide, there's also one new object privilege. Maybe some of you know that when you create a foreign key where the child table and the parent table sit in different schemas, you have to grant this references object privilege in order to be able to create a foreign key that crosses a schema border. Well, the same is true with assertions. Let's assume we're going to create an assertion that's going to mandate that departments cannot be empty. But debt lives in a different schema than emp. So debt lives in the HR schema and emp lives in the AW schema. Now, if I want to create that schema, I have to choose one of the two. I either have to create it here or create it here. Where do you create it? It's up to you. The enforcement will be exactly the same. But if you create it in here, where I'm going to say there doesn't exist a department which doesn't have an employee, so there are no empty departments allowed. When I create it here, I have to reference emp by prefixing it with the schema because it's a remote table. Yeah, so we do not allow for you to use synonyms in these multi-schema assertions. And if I were to create it in this schema, then instead of having to prefix emp with the schema, I would have to prefix dept with the schema. Otherwise, we cannot resolve which dept otherwise we're going to search for dept in this schema. But now coming back to my new object privilege, if you create it here, then this schema needs to have been granted a certain privilege to use dept in an assertion here. And that's very much like the references object privileges that we already have for foreign keys, but now it's called the assertion references object privilege. Yeah, so HR has to grant assertion references on dept to the other schema for the other schema to be able to create the assertion in this schema. And vice versa, were you to create it in this schema, then emp needs to be granted assertion references to the HR schema. Otherwise, we are not allowed to use it. Now, this is a very powerful object privilege to give away. I just want to quickly make you aware of this, because if you grant this object privilege to a different schema, then the owner of that different schema, they could basically create an assertion like create assertion, whatever name you want to give it, not exists, select star from your table. And once that insertion is created, you cannot insert any row anymore in your table. Yeah. So it's a very powerful object privilege to give away because your table will be involved in assertions created by the other schema.
Yeah, good. That's a great point. There's just a question that's come in on this as well about the DB developer role, so the create assertion privilege. So that those of you not familiar, in 26 AI, we introduced DB developer role, which includes pretty much all the create, create table, create view. Create assertion is included in that. So, if you've got that role, you can also create assertions.
Okay, let's now quickly go to the first demo. So I'm gonna create those two tables that I talked about earlier. So I have my department table, I have my employee table. I have a bunch of departments, each of one of the types that I discussed earlier. And I actually have a controller here who works in 20, and 20 is the finance department, right? So let's create that assertion. So I'm going to create the assertion controllers must be working in a finance department, which is the SQL that I showed you on the slide deck earlier. So I'm currently able to create it because the controller is indeed working in finance. Were that not the case, I would have gotten an Oracle error while trying to create this. But if I now try to move the controller, which is employee 200, if I try to move it to the development department, 10, I immediately get a SQL assertion failure. Yeah, this is not allowed, this update, and it basically says this assertion is violated, so I'm not going to allow you to do this update. Let's create two more assertions. This is the one where we mandate that there can be at most one president in the employee table. Now, currently there is just one president, so this should successfully create. And if I then try to introduce a second president by promoting myself to also become a president, then I get the assertion failure of the at most one president assertion. Let's do the last one, saying that there must be a president. And again, I'm able to create this assertion because the current contents adhere to this Boolean expression. And if I then try to delete, to remove the president, I should get an assertion violation again, right? And we're tracking these assertions in user assertions. So you see here that this is the controllers in Fin. I've all created them in the default mode, so they're all enabled and validated, and default also is not deferrable immediate. So this is the one that I created, and here are the other two that I just created.
So just while you're showing these, Tone, and kind of a general question on the join syntax. So someone was asking, we've got like Oracle style joins with the where rather than join on. Could you give a bit of explain a bit about that? Or
Uh,
why is that basically?
so currently NZ join syntax is not yet supported. It's on our to-do list. And you're going to ask, Jesus, why is that the case? So this was a really big and complex project to implement. Inside the Oracle kernel, everything that has to do with NZ joins is basically separate code base. And we have not touched that code base yet, or we're not using that code base yet. But NG join support should become available in some future release for sure. But at the moment, it's not allowed. Does that answer the question?
I think so. Hopefully we'll yeah.
That's probably to do with the fact that I was the project lead here as well. But
Yeah.
let's not get in that.
Well, I think there's a general thing, like all join syntax is converted to Oracle syntax internally anyway, right?
Yeah,
So,
yeah,
like you say, we're kind of working at the lowest level here, really, aren't we? So,
yeah, yeah, yeah. Yeah, it's you learn a lot when you do a project like this in terms of the internal code base and the oddities that are around. Um, but let's continue with the assertions here. So I want to make this is to me this is an important point that we're now going to make. I'm going to show you an assertion, and I've given it a very specific name. I've given it the name "Don't do this." So what does this assertion do? Well, let's look at the query first. The query is looking for two employees who have the same employee number yet are different rows. And we're going to say that that's not allowed to happen. So I cannot have two employees with the same employee number. That's basically a primary key, right? So here I'm using an assertion to mimic what the primary key already gives you through a unique index. Yeah. Now, why do I say don't do this? Obviously, a primary key will perform better because for assertions, we had to implement, since they are generic constraints, we also have a generic constraint, sorry, a generic assertion validation engine in the database. And it will never match, this will never match the performance that the primary key can give you. Yeah. This will always be slightly more overhead when you implement the primary key as an assertion. But assertions, they can cover everything. Because here's another one. Also, don't do this. Here I'm looking for an employee for which the department to which it points does not exist. And I'm saying that such employees are not allowed to be there. This is the assertion equivalent of a foreign key. And again, it would be better to just keep using foreign keys and not start implementing foreign keys as assertions. Finally, some of you may already guess this, I can do check constraints as well with assertions. Here I'm looking for an employee whose hire date is less than or equal than the birth date, which would be odd, right? I mean, you cannot be hired before you were born. And I'm saying that that's not allowed to exist. But the equivalent would be to just add a check constraint, check hire date greater than birth date. Yeah, so these two are equivalent, but again, this will outperform the performance of this assertion. Yeah, so please keep using the constraints that you already have and only start using assertions for the multi-row constraints that you would have wanted to add to your database designs, but currently never were able to, unless you had to develop your own row and statement triggers to do stuff like that.
I think there's another kind of a general question that's come in is like, well, why can't check constraints do what assertions do? So
Because in the SQL standard, inside a check constraint, you're only allowed to reference columns. You're not allowed to put subqueries in here. Yeah. So that would be my first answer. The second answer would be, well, if you were to allow to put subqueries in here, so for instance, put this whole not exists in an alter table add check clause, then you're gonna run into situations where your assertion is referencing more than one table. If it's referencing more than one table, on which table do you then create it? I mean, a check constraint is attached to one table, or do you then have to do it on each of the involved tables? Yeah, so that's why this assertion object is an object type in itself. It's no longer attached to a table because you can reference more than one table in assertions. Anything else for now?
yes, I think there's one other thing coming. There's someone who's asking about performance, but I think you're going to talk about that
I'll come
later,
back
right?
to
So
that.
we'll
Yeah,
come
yeah,
back to that.
yeah.
But they're saying there's another one about primary key violations. You can catch, if you've got duplicate key error, you can catch it in a when, PLC equal when block.
Mhm.
Um, can we do something similar with assertions, Nathan?
Yes, you can, right? Because we're throwing a new Oracle error, right? We're throwing the Oracle 8601 error, and you can just catch the 8601 error. Just define an exception handler for it, maybe even create a named exception variable for it, and use pragma exception in it to set it to that number, and then you can catch it, right?
Yeah. Yeah, I think there's some other people. I think people are starting to think about this and think about performance and impact and stuff. So there's some questions coming in around those. So I think Tone's going to cover these things, right?
Yeah, 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 yeah. That's why I have them in the deck. Here, that's actually my next topic now. Yeah? What about
Perfect.
performance? So there's two questions here. The first question is, do we validate every SQL assertion for every DML statement that you execute in a transaction? And the answer is no. We only spend time on the SQL assertion when your DML is such that it, what we call, could have potentially violated the SQL assertion. And I'm going to explain what I mean here on the next few slides. The second question that we obviously get a lot is, well, okay, so suppose I executed such a DML statement that could potentially violate. Do we then validate the full Boolean expression of the SQL assertion? And here the answer is again not yes, it's no. We do incremental revalidation whenever possible. And you'll notice that in the majority of your SQL assertions, this is typically possible. So let's discuss these two questions in a bit more detail. I'm going to use this last example that I gave you earlier in the deck, where we mandate that every manager must have a clerk in the same department. Yeah, so I cannot have a manager that doesn't have a clerk in the same department. Now, the first question I'm going to ask is, which type of DML statements would require validation? Let's say, let's look at inserts first. If I insert a trainer, would I then have to revalidate this SQL assertion? An insert of a trainer? Well, obviously not, right? Because trainers are totally not related to this SQL assertion. There's only one type of insert where we should have to spend time on this SQL assertion, and that's when you insert a manager. If you're not inserting a manager, we should not spend time on this. But when you insert a manager, we need to revalidate, because you could be inserting a manager into a department where there's not yet a clerk available, right? So this SQL assertion actually would mandate you to first insert the clerk and then the manager, or you'd have to create the assertion as deferrable initially deferred. And the last demo will talk about that. Now let's look at deletes. What type of deletes are potentially violating with respect to this SQL assertion? There's only one type of delete, a delete of a clerk. All other deletes are immune. They cannot change the validity of this SQL assertion. Yeah, so we have two very specific events that you need to do in your transaction for us to have to revalidate this SQL assertion. Now, once you know the inserts and the deletes, you can deduce the type of updates that could potentially violate this SQL assertion. The first one would be if you promote somebody to become a manager, because somebody's updating the job to manager is basically introducing a manager. It's sort of like the update equivalent of inserting a manager. Similarly, if you update the job of somebody who's currently a clerk to no longer be a clerk, that would be the update equivalent of deleting a clerk. Yeah? So now we already have four events, four very specific events. All other types of updates are again can never violate this SQL assertion. But there's actually one more update, because you need to look at all the columns that are involved in the assertion. There's also department number involved here. It's not just job. We also use department number. So you need to think about updates of department numbers. So, and that's the fifth update, the third update and the fifth event. When you move a manager or a clerk, but only a manager or a clerk, when you move them to a different department, which would be a DEPNO update, that would also be a potentially violating DML statement with respect to this SQL assertion. Yeah? So when you create a SQL assertion, we parse the SQL assertion and we determine these five events. So we deduce, okay, these are the five events where we need to spend time on this SQL assertion. Now, and at the end of a DML execution, so we first have your DML statement executed. We need to check if your DML statement did one of these five things. Now, that we have to do. Yeah, but that's a relatively cheap check, because what we're doing under the covers is we're keeping track of the rows that you inserted or deleted or updated, and we can quickly check, did you insert a manager or did you delete a clerk or did you do one of those three types of updates? If that's not the case, then we're done. Yeah, but this is something that we do have to do. But again, it's relatively cheap to the second step. The second step would be, okay, well, if you did one of these five things, then we need to ensure that the assertion is still valid or not. Because these five DML statements can potentially violate the SQL assertion. Yeah? So how do we then validate? So you ran one of these five statements. We saw that you ran one of these five statements. Now we have to validate the SQL assertion to make sure that your DML is allowed or not. We do that by running a query. And we do that by running a modified version of the query that you gave us. Oops, sorry. A modified, so you gave us a query here under did not exist. And we're going to slightly modify this query and going to run it so that we actually do it in an incremental manner. So let me explain what we do here. So next to determining those 5 events, at compile time, we also determine if the assertion is eligible for incremental revalidation. Yeah, so in our parser, we have some smart code that looks for, can we do this in an incremental manner or not? And in this case, the answer is yes. We can do this at the department number level, which means that if you insert a manager in department 10, we only need to revalidate if there's a clerk in 10, because all the other departments will still be valid. Yeah, but if you insert a manager in 10, we need to quickly check, is there a clerk in 10? If yes, we allow your insert. If no, we give the Oracle error. Same for a delete. If you delete a clerk from 20, we need to quickly check if 20 still, if it has a manager, and if yes, if there's still a clerk, if there's still another clerk for that manager. Yeah, if yes, then we allow your delete. If no, we raise the exception. And similar for the updates. So how we're going to do that, we're going to modify the query that you gave us. Now, depending on the type of DML, insert, delete, or update, and the structure of the SQL assertion and the node, we call every reference table that you have in your assertion, we call those nodes. Depending on the node that was touched by your DML statement, we have different modification strategies to implement an incremental revalidation. So I'm going to give you, I'm going to show you the one that's probably the most prevalent, that will happen the most often. If I insert a manager in 10, again, I only need to revalidate if 10 is still okay. So what we're going to do is we're going to replace, no, I forgot to mention, inserting a manager in 10 means you touch this emp table. You do not touch this emp table because you're inserting a manager, and this is the emp table that's about the managers. This is the emp table that's about the clerks. So if you insert a manager, we're going to replace this emp table. And we're going to replace it with an object that returns the rows that you just inserted, actually only the managers that you just inserted. Yeah, so conceptually, this is what we're going to do. The actual code looks a little bit different. You can find it out when you do a SQL trace. But we're going to replace the emp table with an inline view. And the inline view selects from an object which I name here inserted rows. And these are the rows that your insert statement just inserted. And if I insert a manager, this will just return that manager that you just inserted. Yeah, so I'm going to look if you inserted a manager. Now this row will also have the department number into which you inserted the manager. Yeah, and we're not touching the alias here. So E1 will still be E1, which means that the rest of the SQL assertion will still be compilable. And the E1, which is correlated in which is used as a correlation predicate in the nested subquery, will then make sure that we only quickly check that department whether there's still a clerk. Yeah. So if you look at the execution plan of this is a really quick anti-join where we have a single row here, and then we anti-join into emp again using that department number and see if the clerk is still there. If there's still a clerk there, I should have said. Yeah. Now, I'm going to make a statement here, and the statement is that this query, performance-wise, is equivalent to what you would have coded yourself in a combination of row and statement triggers, where in row triggers you track the department number and you then use it in the statement trigger to prevent the mutating table error, etc. So it's performance-wise is going to be equivalent. Yeah, so this is how we implement, in this case, an incremental revalidation strategy. We take the query, we modify it, and we make sure we only check the department into which you inserted the manager. Now, it is your responsibility, just like with foreign keys. If you have a foreign key, it's your responsibility to put an index on the foreign key in the child table, right? Because if you don't put an index on the foreign key in the child table, then when you delete a parent, we're going to have to do a full scan of the child table. So you're already giving us that index to make sure that certain events where we need to check foreign keys are efficient. And the same is for SQL assertions. Yeah, so it's your responsibility in this case to at least give us a department number index. You may even want to consider adding the job column as the second column in order to prevent the table access by row ID. But this is just the same type of performance optimization that you would have done had you built your own triggers for this. So again, we have different strategies where we do this, but in most of the cases, and actually in all of the cases but one, we can do fast revalidation. So I've given you 4 examples so far. We have another dictionary view, user assertion dependencies, where we track the tables that you are referencing in a SQL assertion. And we are also giving you whether or not we will be able to do a fast or we have to do a complete revalidation when you do a DML statement that potentially violates the SQL assertion. And we're also giving you the validation event more at a high level, so not very detailed in terms of inserting a manager or deleting a clerk. So we're doing, if I look at the manager without clerk, emp is referenced twice. There's actually a number against this table again, which means you'll see that this would be the first employee reference in the text of the SQL assertion. This would be the second reference. So this would be the one about managers. And if you insert a manager, we can do fast revalidation, and it will happen when you insert or update the way that I discussed on the slide earlier. And when you delete a clerk on the other emp table, again, we can do a fast revalidation. So there's only one here where we cannot do a fast revalidation, which would be the president must be there. Now, think about that one. If you have to code this yourself, you cannot do a fast revalidation for that either. The president must be there because of the top level exists is such that the only thing you can do is check if there's still a president. Yeah. Obviously, the event would be deleting a president or updating a current president to not be a president anymore. And the only thing you can do is run the query that you gave us. Select star from emp where job equals president. Yeah, and hopefully you have an index on job column to make that query run efficient. So that's the stuff that I wanted to talk about performance. If you have any more questions about performance, please let's put them at the end of the talk because there's other stuff that I want to talk about first. So what about concurrency? I'm guessing most of you know that foreign keys can impose a serial execution order on 2 different transactions that try to mess up the foreign key. Let's look at the foreign key scenario. Let's assume I have a department 42 in the department table, and there's no employees for that department yet in the employee table. And now I have 2 transactions going on simultaneously. Transaction 1 is inserting the first employee in that now still empty but no longer department 42. So it runs the insert, but it doesn't commit yet. Now, at the same time, in transaction 2, who doesn't see this insert yet because it's not committed yet, transaction 2, I just see an empty department and I decide to delete the empty department. So I delete from dept where department number is D42. So this delete will be blocked if you have a foreign key in place. Because if we do not block this delete, and you're allowed to commit this, and you're allowed to commit this, then suddenly we have an employee in department 42 but department 42 doesn't exist anymore. Yeah? This block will be released the moment I do a commit or a rollback here. If I do a commit, the delete will get a foreign key violation. If I do a rollback, the delete is allowed to proceed. Yeah? Now, we have the same issues with SQL assertions. In SQL assertions, there will be scenarios where we have to enforce a serial execution order of DML statements going on in concurrent transactions. Let's stick with the same SQL assertion. Yeah, all managers must have a clerk. Now let's assume I have a manager in department 42 and also two clerks in department 42. Yeah, so the assertion is true. And now I have two transactions. In one transaction, I'm going to delete one of the clerks, and in the other transaction, I'm going to delete the other clerk. So let's start with transaction one. We already identified that deleting a clerk is an event where we have to spend time on revalidating the SQL assertion. So when you delete a clerk, we're going to run the validation query the way I showed you, and we're going to check if there's a manager, which there still is a manager, and whether there's still another clerk. And there still is the second clerk is still there, right? So this delete will be allowed to run, but again, we do not commit yet. Now, if at the same time I'm going to delete the other clerk here, well, the same code is going to fire. We're going to detect that this is an event where we need to spend time on revalidation. But if we were to run the same revalidation query again, then we're still seeing the other clerk, right? Because this delete was not committed yet. So this delete must be forced to be blocked until this delete is either committed or rolled back. Now, the way we do that is in the same incremental manner as the revalidation queries. In some sense, we need to lock value D42, communicating to other transactions that you shouldn't mess with D42 because I currently already have a transaction where a potentially violating DML statement with respect to department 42 is outstanding, needs to be committed or rolled back. Now, what we're not doing is we're not going to put a row lock on the department row. This is all going to be done via a new enqueue type. We're going to use enqueues inside the database. We never lock rows or tables. What you're going to see is when the situation like this arises, and I'm going to demo it to you now, is a new wait event, enqueue an SQL assertion DDL DML. So let's demo this exact scenario that I was talking about on this slide. So I modified the contents of the employee table. I'm not using, so I'm having department 10 instead of 42, but there is a manager and there's currently two clerks for the manager. I dropped all the other assertions because I just want to focus on this assertion, the manager without a clerk. Yeah. So this assertion is currently enabled, validated, and the current contents adhere to the SQL assertion. Now here I'm going to delete clerk 1. Yeah. Again, everything that I was talking about has happened. We noticed that this was one of the 5 events. We ran the incremental revalidation query, and we still see that clerk 2 is there, so we allow this delete. Now I'm going to switch over to a different SQL Plus prompt, a different session. So in this different session, I can still see clerk 1, right? I've deleted clerk 1 here, but because it's not committed, it's still visible. Now here I'm going to delete the second clerk. The moment I try to do that, it's going to be blocked. Very similar to a foreign key scenario, because we're going to have to wait for the other delete to commit a rollback before we can proceed. Now let's look at the logs. So I'm now switching to a DBA, sysdba window here, and I'm querying $NQ logs. So in $NQ logs, I see my 33 and my 34 session. So the 33 session is the session that was already successfully executed, the delete of clerk 1. The 34 is the one that's currently blocked. So in the 33 session, you'll see a bunch of NQs that we have acquired. Now, NQs, they are identified by an ID1 and an ID2 value. And you see that we have this NQ in share mode, another and one in share mode, and here we have one in exclusive mode. So let me talk just a little bit about ID1 and ID2. So in ID1, we're putting in the object ID of the SQL assertion. So 84474 would be the object ID in DBA objects for this SQL assertion. So what I did in this query, I joined to DBA objects to show you that this is actually an NQ that we took out because this SQL assertion is currently potentially violated by this session. Yeah. So you can really in detailed manner see which SQL assertions are currently the cause of NQs being held in which sessions. Now the ID2, we're using ID2 to encode the department number value in. Yeah. So, but we have to do that per node. So here you see that, we basically compute a hash on the node and the department number value, and the hash will be the value for ID2. So here you see that in this NQ, where we had gotten the X mode, the same NQ is the other session is trying to get the same NQ also in X mode, right? But since I ran the query, it was already waiting for 23 seconds to get it, yeah, because it's requested, but it can't get it because it's blocked by this one. If I look at $session, in $session, I can see the event that session is currently in. So my 33 session, which deleted the first clerk, it's just in the SQLnet message from client. It's waiting in SQL Plus to send the next DML or the commit or the rollback. But the other session is now in this wait event and QAN SQL assertion DDL DML. Yeah? And via $NQ log, you can diagnose what's going on. Now, going back to my sessions, what's going to happen if I commit here? The moment I commit here, the other session will be released. It will not be able to see clerk 1 anymore, and it should get an immediate violation. Yeah, so I'm switching back to the other one. It's now been released and it's received the SQL assertion violation. Yeah. So this is something you need to be aware of. Now, I think given the business rules that you implement with SQL assertions and the mix of transactions that you have, the likelihood of you running two transactions at the same time that involve the same incremental level, A, will be small, and B, if it happens, in OLTP, the commits will typically happen very fast, right? You don't have long-lasting open transactions. So certain transactions can temporarily be in this new NQ before they get released and then either proceed successfully or rightfully get the SQL assertion violation because of us having to serialize your transactions to make the revalidation queries run correctly.
The interesting question came in on this one, actually. They're saying if it's the same demo, but you had three clerks, so basically everything's the same except there's three clerks to start with, what would happen? Would the second delete still be blocked in that scenario?
Yes, it would. Yes, it would. That's a good question. Yeah. Yeah, it would be blocked. So we're not doing something like reservable. What's the feature called?
Oh, the reservable
Yeah,
columns.
we have this
Yeah.
because that's the question leans towards this. Can we
Hmm.
implement sort of like a reservables thingy here as well?
Hmm.
Not sure if we could. It's going to be complex to do it in a generic manner, I can imagine.
Mhm.
But no, no. So with three clerks, the second one would also be blocked in the current implementation. Any other questions right now for concurrency?
There's quite a few others, but I think if we'll probably come
Yeah.
back to some of these at
So,
the
so
end.
this, Chris, this whole concurrency thing, I
Mhm.
think I could talk about this for a full hour to show you all the scenarios that can happen, right?
Yeah, yeah.
And to give much more detail on those who would like to get more detail.
Yeah, I think there's some more generic questions about assertions themselves. So I
Okay.
think, yeah, if you continue, we'll see, have some time for questions at the end, I guess. Yeah.
Okay. Two more topics. This is the first one. So now going back to this negation thing that I mentioned in the beginning of the talk, right? You've seen a lot of nots in not exist, nested not exist, etc. Yeah. So continuing with the same example, every manager must have a clerk. This is how we would do it in natural language, right? Every manager must have a clerk. But currently in SQL, we have to implement it like this. There cannot be a manager that doesn't have a clerk, with the nested not exists. And this can become really awkward if you even add another nesting level. Let's contrive an example here. Let's assume I have my debt and emp table, but employees has a child table called criminal record, and employees can have criminal records. And if an employee has criminal records, we consider the employee to be a criminal. And the business rule I want to implement is this one. Every department must have at least one employee that's not a criminal. Yeah, so departments can have lots of employees, lots of them can have criminal records, but there must be one employee who does not have criminal records. There's no natural way currently in SQL to implement this. We have to do it in the awkward way. And the awkward way would be there cannot be a department that doesn't have an employee that's not a criminal. Yeah, so now I have three negations. And this now translates into three nested not exists. Yeah, so not exists a department for which there doesn't exist an employee which is not a criminal. Yeah, doesn't exist a criminal record for that employee. So I have three levels deep here, which becomes really awkward to understand. I mean, had I given you this first, you would have had trouble trying to figure out that this is actually implementing every department must have an employee that's not a criminal. Now, so for SQL assertions, we're going to introduce a new syntax, optional syntax that you can use to reduce the number of negations. And this is the new all satisfy syntax. So instead of there cannot be a manager that doesn't have a clerk, I can now specify this assertion using this syntax and more use the natural language way every manager must have a clerk. So how does this work? Again, we create an assertion, manager without clerk, check, and then we have all satisfy. In all, we have a subquery which returns rows, and here I'm returning all managers. And in satisfy, I have a Boolean expression. Yeah? So here I have a subquery, here I have a Boolean expression, and the semantic is that this Boolean expression must be true for each row returned by the subquery up here. Yeah? So all managers, I have to specify an alias here. All managers, for all managers, there must exist a clerk in the same department. So here I'm using that correlated alias. Yeah, so instead of two not exists, I now have not, I have zero nots, zero negations. All managers must satisfy there exists a clerk in the same department. And it makes this one also a lot easier. Instead of there cannot be a department that doesn't have an employee that's not a criminal, I can now specify it much more naturally in the way where I say every department must have an employee that's not a criminal. So all departments must satisfy there exists an employee that's not a criminal. So I'm still going to have one not, yeah? But I reduced the number of nots from 3 to 1. All departments must satisfy there exists an employee for which there doesn't exist a criminal record. Yeah, so this syntax is more readable in certain cases where you have the nested negations going on. Now, for us, this is syntactic sugar. When you give us this new all satisfy syntax, one of the first things we do before we start parsing is we recat it back to the nested not exists. And internally we compute on the nested not exists. So the revalidation queries that you'll see for these will again have the nested not exists. But in the dictionary views, we're going to maintain your all satisfy syntax. What time is it? How much time do we have,
We're
Chris?
just on the hour. I think I can hang around for a while, and it seems like people are still hanging around. So it's
Okay, so it would just be 4 more minutes.
yeah, okay.
This demo will be quick. So just one slide on the scope of syntax we're supporting in the first release. So so your SQL assertion has to be a top level exists or not exists, or a top level all satisfy. The subqueries must access base schema tables, and it can be an equi-join of 2 or more tables. And you can have filter predicates in the where clause, logically ANDed or ORed in whatever way you would like them to be. Those filter predicates can be just your regular column filters, the regular stuff that you have in your OLTP transactional queries already, right? Equality, inequality, greater than, less than, between. You can use standard SQL functions. It can be a nest of a mix of nested, not exist and exist, and they can go up to 3 levels deep. So the criminal records example that I gave you, that's the deepest nesting that we allow currently. If you can give me an example where you really need to go to 4 levels, please bring it to me. We couldn't think of one. So currently we support up to 3 levels. And they must be deterministic, right? So you cannot use non-deterministic stuff. Nor can you use PL/SQL functions even if they are declared as deterministic, because you can create or replace a deterministic PL/SQL function, and then suddenly the whole SQL assertion could have a different semantics. And we're not supporting making an assertion invalid and immediately have errors going on in your transactions. So we're not allowing you to put PL/SQL functions in them. Most notably, what we do not support yet is these 4: group by, aggregate functions, outer join, and I think I should add ANSI syntax, ANSI join syntax in this list, as well as the set operators, union, union all, minus, intersect. So very likely we will start a second project, and in some future release start giving you support for these once we get a feeling that this feature is getting traction in the customer base.
Yeah. Just kind of on Tone's point about that, if you start using this and have a new use case for those scenarios, please reach out to either or both of us to let us know. Because the more we hear from you that you need this feature, the more it helps raise internal priority for these things.
Now
Um,
let's give you one last demo. Again, just 2 minutes. I'm going to show you that with SQL assertions we can do the whole deferrable stuff as well, that you are already acquainted with constraints. So I'm going to create an assertion here that says order must have a line. So I do not allow empty orders. So not exists an order for which there doesn't exist an order line. So let's just create that SQL assertion real quick. Yeah, so I got rid of the other ones. I created this assertion, and I've actually used the all satisfy syntax here now. All orders must satisfy there exists an order line. Currently it's enabled, validated, and it's immediate. Now the order and the order line tables are currently empty. If I try to insert an order, because it's immediate, I cannot do that right now, right? I mean, I immediately get the SQL assertion error. On the other hand, I cannot first insert the order line because the foreign key is preventing me to do that. Yeah, the foreign key now doesn't see the order. So the only way for me to fix this is to either make the foreign key deferrable or the assertion deferrable. And in this case, I choose to make the assertion deferrable. Now, there's not an alter statement for that. You have to drop the SQL assertion and then recreate it as deferrable initially deferred. So let's do that. Yeah, I now recreated the SQL assertion as deferrable initially deferred. And now I can insert my order, but I cannot commit yet. If I try to commit, then at commit time, I again get my SQL assertion violation. So I get the current well-known existing transaction that you have with for deferrable constraints, but the nested error will tell you in this case that it's a SQL assertion that caused the 2091. So the only way for me to get this now done is before I commit, I have to insert at least one order line. And once I have inserted the order line, I can successfully commit. Yeah. So again, just the same as deferrable foreign keys, the same type of behavior, actually the same error message, top level error message as well in this case. Okay, with that, that's actually my last slide. I'm here still if
Yeah.
there are some more questions.
Yeah, there's
Yeah.
still some
Okay.
questions, so I think that was great tone. Like I say, if you want to know more about this feature, please reach out to us. There'll be expect to see more blogs and content coming in the future. There are a few other questions which I think are worth addressing. Someone's asking, what about null values and assertions? Is there anything we need to be aware of?
Yes, there is something you need to be aware of, and it has to do with the join columns. If you use joins in your SQL assertions, we mandate that either the join columns are defined as not null, or that you add is not null in your SQL assertion. So if I, for instance, look at this example, um, let's say depno is not defined as not null. I would have to add here e2.depno is not null and the same for e1.depno. So that's a restriction. If your join columns are optional, you have to add the not null constraint in the assertion, because with nulls, you basically open up a can of worms. The semantics vary and differ depending on what the join structure is like. So we decided we must mandate that join columns are guaranteed to have a value in it. With respect to nulls in filter predicates, there's no restriction. I mean, they would operate the same way as regular query processing now works.
Okay, cool. Thanks, Tone. Another kind of interesting general question. Do SQL assertions make use of existing constraints, existing tables constraints? I guess check and foreign key and things like that.
Well, the query that we generate um, is just parsed by the optimizer, right? So if that query can benefit from check clauses or primary key or foreign key constraints, the optimizer will take care of it. It's not something that we added to our code. We just run the query as a regular query, be it at a recursive level, but all the constraint transformations that we have in the optimizer, as for instance, as join pruning, if it's applicable, joins will be pruned but in our validation queries.
Hmm. Yeah. So I think that's the great thing about Oracle database, isn't it? We've got this underlying stuff and we can build on top of it and just use what's there, right? Yeah. A few other kind of things. Okay, for all satisfy clauses, the top query in the all part has to be a query select from, or can it just be a table name? I think they're saying, can you just put list a table name, or do you have to say select
No,
star
it has to
from?
be a query. It has to
Yeah,
be a query. Yeah,
yeah, it has to
yeah.
be a query. With respect to future requirements, the hardest real-life requirement I've seen is to prohibit cycles in hierarchical relationships. For example, every employee must be directly or indirectly under a president, so you can't kind of look back. Yeah, that's
Yeah,
yeah.
connect. We do not allow you to use connect by
Hmm.
in the queries, so that would be excluded from assertions.
Hmm. Yeah. I mean, you could probably do it to some degree, like three levels deep potentially. A president, or there might be a limited way of doing it. You
Yeah,
can't,
yeah,
you
yeah,
can't
yeah. So
have,
that you prevent having to use a connect by, you mean?
yeah.
Yeah,
So just chain a couple of net not exists or exist, but yeah, it would be limited to that three levels that we've got at the moment. That might be an interesting,
yeah,
yeah. If you talk to us in more detail, send us in more detail because I think that would be an interesting one to explore, I think. Yeah. Alrighty then. I think that covers all the main things. Other questions and comments. So I think so. People saying very
yeah.
interesting thing. Yeah. Anything last final things you want to say, Tone?
Yeah, no, no. Just if there are other questions, just email the two of us so that we can see them both, and then we'll look at them and we'll send you a reply.
Yeah, exactly.
Yeah.
Alrighty then, folks. All that's left to say is, yeah, join us again for next month's session. I'm planning on talking about fourth normal form, the kind of one of the forgotten normal forms. People tend to overlook it a bit. So I'm going to be diving into some details of that. Otherwise, really hope you enjoyed this. More importantly, hope you learned something. Massive thanks to Tone for joining us today. Go out, enjoy the rest of your day, and see you next time.
Okay. Yeah. Cheers. Bye bye.